Cool. Okay, tomorrow y'all are going to take an assessment over what we have talked about so far, which is what?
Mass,
Chemical change.
Temperature.
Temperature.
Magnetism.
Thermometers. Magnetism.
We're taking a test in like every class now. We took one. No, yeah. We take one.
What else have we learned about? Yes. Yes, the triple beam balance. Good.
And
What about the states of matter? What are the states of matter? Solid, liquid, and gas. What? We did learn a little bit about. We did talk about magnetism. We also. Sorry, I needed to make a note while we were talking. We also talked about when they change from different states, from different states of matter, from solid, liquid to gas. We talked about that. Anyways, okay. So let's talk about what tool do we use to measure temperature? Thermometer. An easy way to remember that, which I feel like most of you would already know that, but the prefix thermo means what? Thermo. Heat. Yes. And so meter means like what you would measure something. So measuring heat. Thermometer, thermometer. Hope that connected somewhere. Okay, what is the tool we use to measure mass? Triple beam balance. Good. Ew. Triple beam balance. Yes. What? That's on there twice. That's weird. What tool do we use to measure magnetism? A magnet. Good. Way to go. At what temperature does, and reminder, we use Celsius in science unless I tell you differently. What temperature does water begin to boil?
100 degrees Celsius.
Everyone say boil.
Boil.
100.
100.
Good. Okay, and then what temperature does water freeze in Celsius? 0. Good. Very good. Everybody say 0. And then say freeze. Cool. What is the red matter inside of a thermometer? Mercury. Good. Mercury is what is inside of a thermometer, and the way it works is it's inside of the bulb, Mr. Sorrentino. And there's the mercury inside of the bulb of the thermometer, and whenever it's colder temperatures, what happens? It goes down, but the mercury kind of like contracts, right? It shrinks down into the bulb. That's why it goes down, because it can all fit inside of the bulb, the bottom part of the thermometer. When it gets hot, what happens? It goes up. It expands, so it can't all fit in the bulb anymore, and so it goes up. So yes. The larger the number, is it hotter or colder? Hotter, right? So the bigger the number, the hotter it is. Cool. Does anybody have any questions about how to read a thermometer? Okay, we're going to keep rolling. What about mass? When we're using a triple beam balance, how does it work? Let me grab one and we'll just chat about it. Okay, so how do we measure mass with a triple beam balance? Okay, we move our little notches, but in what order?
The biggest to smallest. Smallest to biggest.
Thank you, girl. Okay, so this right here would be like your smallest one that you are going to use. And you are going to place your item on here. So I'm going to measure these tomatoes. Some of them are spoiled. Anyways, okay, so I put my item on here, and then I'm going to scoot the first one, right? And nothing happens, right? Because it's not heavy enough. Like, it's not enough. So I'm going to scoot it back. And then I'm going to, thank you. I'm going to scoot this one in the back, which is like the middle one. That's the tens place, if we're going to talk about math. And this would be like your ones place and also your decimals. And then you would scoot back to your tens place and you scoot one over at a time. And you're waiting on the scales to tip. And they don't. So you're going to scoot it back. And then you're going to go to too heavy. There we go. So we know that it has to be on 100. Too much. It also doesn't help that I'm holding it, so it's just not steady at all. But anyways, you're going to move these as they go, right?
Yes.
So let's talk about how you read it. Once you get it to balance out in the middle part right here, how do you read your triple beam balance? Let's just say this is what we had. How does it work? Yes, Paisley.
The number, you can like, when you move it, there's a little like triangle that points down, and there's numbers along the bars.
Mm-hmm.
It'll point up in the corner.
Yes, so there are little triangles that point down for each one of these. I can't even see if y'all can see this. Okay, so for each of the numbers, you have a triangle that points down, and it lands on a number. What order do I read this in? So it's like, if this were on a 3 and this is on a 3, well, that's not a good example. This is on a 2, this is on a 7. Do I have 327 grams? If this is a 3, this is a 2, and this is a 70. What order am I reading in? Biggest, right? So this is your hundreds place, so it's 200. This is your tens place, 70. And then this is your ones place, and if it's exactly on 3, then it'd be 273. But most of the time, it's going to have a decimal there, right? Lots of number line action. There's that. Okay. Does anybody have any questions about how to... Yes.
What do we do with this?
You're going to hold on to that. Wonderful question. Does anybody have any questions about measuring mass with a triple beam balance? No. This is something y'all have done for a while. Just need to go back over it. All right, let's talk about magnetic and non-magnetic things, Isaac. What is a couple of examples of things that are, what are examples of magnetic items? A spoon, fork, a nail. Give me like 2 more. Or here, huh? Okay. Okay, what are some examples of things that are not magnetic, Daniela? A pencil.
Table
Mm-hmm.
and a chair.
Okay, good. Let's talk about materials. So, like, materials that items are made out of. So, like, cloth would be one, or paper, or nickel, or wood. What are some materials that are not magnetic? Yes.
Copper.
Copper, good. So, pennies. Are pennies magnetic?
No.
Everybody say this out loud. Pennies are not magnetic. Say it again with your chest. Pennies are not magnetic. That is like the go-to question to mess every 5th grader up in their whole life. Is a penny magnetic? And everyone wants to think that it is because it's like kind of like metallic and it seems like it'd be in that family. But it's not. She's not magnetic, okay? Okay. Pennies are not magnetic. Okay. Let that sizzle in your spirit. She does not belong in that family. Okay. What are other examples of materials that are not magnetic, Eva? Plastic. Good. Yes.
A turtle shell.
A turtle shell. I was literally about to say that.
Rulers. Tapes. Hot glue.
What else? Yes.
That table.
Bracelet.
Basically everything that's not metal.
Basically everything that's not metal. Okay. Yes.
Wood. Floor. Ceiling.
Wood, floor, ceiling.
Walls of stores. Aluminum. Walls of
Cool.
stores.
Aluminum. I like that. So what are some things that are aluminum? Yes. Foil. So is foil magnetic? Absolutely not. What about a can? Like a Coke can.
It's not magnetic.
Hold on. She is not magnetic. I mean he, sorry. Whatever.
But he's not
Oh no. Okay, not magnetic. Everybody say aluminum is not magnetic. Again, it is shiny and metallic looking, and she looks like she might be in that family, but she's not. Sorry. I'm all about feminine power. Okay, but for real, aluminum is not magnetic, so don't think that foil or cans like this are magnetic. What about cans that soup come in?
They are. Yes. No, they're not. They're not magnetic. Soup cans? Oh, they're not. N/A and
Let's talk about this. Are they magnetic?
I might have tried to put one on my refrigerator.
Well, they're not actual magnets, so that wouldn't work. But if you hold a magnet to it, does it hold on to, if you like hold a magnet? How many of you have ever seen those can openers that have the top part on it? Usually they're like automatic or whatever, but there's a top part and then it spins, and then whenever it opens, it holds on to the top part. And then you pull the bottom part out, but it like holds on to the top of the can. That's a magnet. So it is. Those are not aluminum, okay? Aluminum is usually pretty bendy and flexible, but those cans are not made out of the same as these cans. That's not aluminum. They are they're magnetic, okay? So soup cans are magnetic. Yes. Sorry about it. Yeah, I mean, it's not like common knowledge, but I just wanted to have that conversation. What's up?
Isn't magnetic because when I was little, I put my cat up to the fridge to see if it was magnetic.
Hopefully you didn't test it by dropping him. Okay, moving forward. So, yes. There.
If cats were magnetic, that'd be so cool.
I'm psycho. All right, so again, to recap, materials that are not magnetic would be cloth, plastic, wood, glass, aluminum, paper, good. Copper, good, yes. Okay.
I know something
Wait.
that's also not
Copper.
magnetic.
Huh?
I know something that is
Fork.
not magnetic.
Glass.
It is light. That's not magnetic.
This is true. Okay.
To be honest, my cats are so stupid. They probably eat lots of magnets and iron filings, so they probably are magnetic. Normal cats are not magnetic.
Okay. Okay. Moving on. We are going to talk about, we talked about the three types of matter, or three states of matter are good. And when we're talking about the molecules of those, they explain what the molecules of a solid look like. Or the atoms inside of the molecule. What do they look like? They're like what? They're like, yeah. So they are organized. They're packed in there. They're just like vibrating against each other. They don't have a whole lot of room to move, okay? What about a liquid? What does that look like? There's room for flowing. They what? What else? They have more space than a solid. There's more room for movement or flowing. And then what about a gas?
Gas is like this.
Gas is like this. It's absolutely crazy bananas. And it's just
It has a lot of space to move.
lots of space to move. Yes. Okay, when something goes from a solid to a liquid, what is that called?
Melting.
Melting. So from an ice cube to water, that would be melting. Solid to a liquid. What about a gas to a liquid? Condensation. Everybody say condensation. Okay, condensation is from a gas to a liquid, and you can see that on the side of your cup sometimes. You can see that whenever there's like boiling water and you have like a paper over it, it'll like collect on there. We have a lid on a cup and it's like really hot in the car, then you can see it on the lid. Condensation from a gas to a liquid. From a liquid to a solid, what is that called? Freezing! Yay! Yes. So it has to get colder. It goes from a liquid to a solid. So when we put the water in the ice trays, they become solid. Please stop. You're distracting me. And then a liquid to a gas is called evaporation. We talked about chemical and physical change. Cool. Does anybody have any questions about what we have talked about? No. Okay. If you remember all of these things inside of your wonderful, huge, beautiful brains, then tomorrow will be a complete, wonderful experience, and you'll be super successful.
I found this little